During the hackathon, we created a proof of concept on how we could bring radiology data into Unity via the digital twin platform. We wanted to do this because the Unity creator community is actively working toward this and should be supported by Unity. This engine is being used by creators to improve the human lives through medical and healthcare industries. The medical applications of the Unity engine are so vast, and the current user experience of some of the WebGL options for current patients are not sufficient. We wanted to improve on that with real-time 3D. Improving medical data visualization will benefit surgical planning and diagnosis. Medical data can be transformed and managed via the digital twin platform. We want to think about a world where doctors can use the DTP to share and manage radiology data with colleagues, patients, nurses, and students, and improve medical care across the board. We want to think about virtual reality, augmented reality, mobile, and PC deployed through the digital twin platform. During the hackathon, we found a few things that were helpful, and we found a few things that were difficult to bypass that caused us to pivot from our original plan. Our original plan was to convert the DICOM to NII file, then to an MGH file, and then an SDL file, but this would have taken 3 days to complete. So we had to come up with another method. We chose, rather than converting the data, we visualized the DICOM raw data as a point cloud. We know that the MRI data is voxel-based and known as the DICOM file. We know that point cloud and voxel scan data are mathematically identical. We can treat an MRI and a CT scan as a point cloud. We also know that an STL does not retain voxel data. We also learned that the DTP does not support point clouds. We were not able to use the 3D streaming on the DTP. In order to move past this, we pushed our data into DTP storage and pulled the data and built meshes on the device. We weren't streaming Unity assets, we pulled the data in and built the geometry on the device. For our proof of concept, we chose to fork a public GitHub repo that had found the same thing that we did regarding point clouds and processed it through the DTP with some simple camera controls and user interface and deployed it to iPad.